simple graphical techniques. So we are going to see several types of graphical techniques. It falls into two parts. The first part is based on the plot is based on univariate data. So univariate data means that we only use one single set data. Okay, first one is histogram. So I believe that you have seen histogram before. It's a bar charts and with different height, and it will show specific trends of the data. So now we look at example 1.12. So sample of a particular type of pavement material were tested for the level of skid resistance. So there are 32 measurements, means that we have 32 data. So when you look at this data, it's not easy for you to figure out what is the patterns, what can we get from data, or what data want to tell us. So that's why we have to use methods. We can use many methods, but now we want to see how are we going to use histogram to measure or to describe this data set. So first, okay, we have to determine the number of classes. So the first bullet point show you the rough method to determine the number of classes. So classes means that finally you will see how many bar appear in the bar chart. So we in bullet point 1, so we use the maximum values, data values, and the minimum data values. But this is not like always you have to use this method. You can try. We have to try and error. Sometimes we can use more classes, sometimes we use less classes. But the thing is that if we use two, if you only keep to minimum number of classes, say for example 2. So if you only have two bar in the histogram, you won't be able to describe the trends. So that's why we cannot use only 2s. But if you use too many, it will dilute the difference from one level to another level. So you will see that there's more bar if, say, for example, you go for 20 bar. So that's why we have to strike the balance. So this first bullet point just serves as a guide. So the other one is what we call the class width. So if you determine that you want to have 8 classes, then you have to know what is the class width. So this is also arbitrary. So now, okay, say if we follow the first bullet point, we want to go for 8 classes, then we will start from first column. 96.9 is the smallest numbers. Since we have predetermines that we want to go for class width is equal to 1, so that's why 96.9 to 97.9. The second class is 97.9 to 98.9 until finally we come to the maximum value 10.9. So now the second column, class intervals. The class intervals, so you will see that when we look at if we look at the first column, the maximum value, the upper range of first class 97.9 is equal to the minimum, the lowest range of second class 97.9. If we have one value which is equal to 97.9, then we will have problem to classify whether we want to classify it in the first class or the second class. That's why, okay, click the second column, class intervals. Okay, we just plus minus 0.05. So that's why the upper level for first class is 97.85. The second class lowest is 97.9. So that there is no overlappings, and we will have the classification of data problem. And the third point is midpoint. When we draw the histogram, the x-axis, we don't want to put class interval as a labels. So it will make the histogram look clouded. So that's why we get the middle between the lower bound and the upper bound for each class. Then to use it as a representative, as a label to represent each class. So now the fourth column is what is the number of data fall into each classes. So that's why for the first class we have 2, 2, 1, and so on. Then the total is equal to 30. Okay, then the relative frequencies is what is the percentage for the first class, 2 over 30. So you will get 0.07, and we do the same thing for other classes. Finally, you will get the value must be equal to 1. So once we get ready these tables, then we can draw the histogram. Okay, so now you can see the histogram representing by the ball. Okay, then you will see the trend. You will see that you will see that the maximum is in the meters. So the skid resistance is concentrate more on around like hundreds and 101. So there is small percentage fall into very a lower level of skid resistance, and only a small percentage fall into highest skid resistance. So at least when you see this, observe this histogram, you can see the pattern and you can describe the characteristic of level of skid resistance of the data. Okay, example 2. Okay, we use the speed, the vehicle speed measured by police. So there are 25 vehicles. So these are the data. The same thing to build the class interval, midpoint, frequency, and also relative frequencies. So now you see the histogram. So what can we say? If the speed limit is 90, for example, if the speed limit is 90, so you can see that how many of them violate the speed limit. So 8, 3, 1. So it means that 13 out of 30, there are 13 of them exit speed limit, and others is below the speed limit. And if you go by percentage, then you will see that the percentage is there are 52% of them drive above beyond the speed limit. So that's why this is considered quite serious, because more than half of the driver drive above the speed limit. So this is how we use the histogram to describe the data, to understand the data. So I think this tells you the purpose and also the applications of the histogram.